Hello learners, welcome to this course on Arduino Mega Board programming and simulation. So in this video tutorial, I will be discussing about how to perform a speed control and direction control of DC motor. So first, let us discuss about the basics of DC motor. So a DC motor is a direct current motor which translates electrical pulses into mechanical movement. So the polarity on the leads of the DC motor determines the direction of rotation. So for example, if I have connected a DC motor which is a two-terminal device, so one end of the terminal I connect it to positive terminal of the battery and the other end I connect it to the negative terminal of the battery. Let us assume the motor rotates in clockwise direction. If I change the polarity, which means the first end I connect it to negative terminal of the battery, second terminal I connect it to the positive terminal of the battery. So here you can see the change in polarity of your battery, which means now the motor will start rotating in anti-clockwise direction or counterclockwise direction. And the DC motor moves continuously. It gives a continuous rotation. So here I have showed a sample image of a DC motor. So if we see the physical construction of a DC motor, it will have stator windings. So this outer part, this electromagnet which is named as north, the south poles are nothing but the stator windings. So this stator windings, when it is given with a current passing through this coil, it will produce a constant electric field. So and we have a movable rotor. Again, this movable rotor is also having an electromagnet principle. So when we apply some current onto these coils in the rotor, so it will produce a magnetic field and it will distort the magnetic field produced by the stator windings. So due to this distortion, a torque will be induced and the rotor starts rotating. So that is the basic principle behind your DC motor. So now let us see how we can vary the speed of a DC motor. So we can vary the speed by three different methods, either by changing the load or by increasing or decreasing the voltage rating or by increasing or decreasing the current rating. So usually the DC motor has 2 RPMs. So it is termed as no load RPM or loaded RPM. So no load in the sense, if we have not connected any other equipments or objects to the motor, then this is called as a no load condition. So loaded in the sense, if we have connected physically some object or some things to the motor, then the motor is under loaded condition. Usually the manufacturer's data sheet will say about a no load RPM. So for example, when we purchase a motor for 100 RPM, which means it is under no load condition. So before connecting any load to the motor can rotate at 100 RPM maximum. So here this no load RPM can be varied from a few thousand to tens of thousand values. So by changing the load, we can change the speed of a DC motor. The second parameter is current rating. By changing the current rating, which means by supplying current to the rotor coils, so we can change the speed of the DC motor. So the current rating is defined as the current consumption of a DC motor when a nominal voltage is applied with no load condition. So usually this current rating can be from 25 milliamperes to few amperes of current. And the third factor by which we can vary the speed is using the voltage rating. As we increase the voltage, the RPM also gets increased. When I increase the load, then what happens? The RPM gets decreased. So in order to compensate for that RPM, what we can do is we can either increase the current or voltage. Thereby we can able to maintain a certain RPM. The third interesting or the fourth interesting method by which we can vary the speed of a DC motor is through pulse width modulation. So pulse width modulation is nothing but PWM signal. So in PWM signal, we will be generating a square wave. with different on times. By varying the on time of a square wave, we can able to change the speed of a DC motor. So if I have a wider pulse, then the speed will be higher. If I have a narrow pulse, then the speed will be lower. So this pulse width modulation can be used for adjusting the speed of a DC motor. So this square wave, usually this width of the pulse will be represented by a duty cycle. So duty cycle, it will be measured in terms of percentage, which is nothing but the on time divided by the total period of the square wave into 100. So this gives the duty cycle. So this duty cycle, which means the on time in the total period, can be varied. So by changing this, I can able to change the speed of a DC motor. So for example, here I have shown some figures in which you can see the total time, which is T on plus T off, remains same for all the 4 waveforms: signal A, signal B, signal C and signal D. For all the waveforms, the T on plus T off remains the same. But you can see the change in the on time of a pulse. In case of signal A, I have 50% of the time out of total time period where I have a on pulse. Whereas in the second case, only for the 10% of the time in the total time period, I have on pulse. In the third case, this 30% of the total time where I have a on pulse. Same way, in the fourth case, I have 70% of the time where I have a on pulse in the total time period. So by varying this on time, what happens? The amount of energy given to a motor is changed, due to which the speed of the motor gets changed. So this we say it as the first signal A is nothing but 50% duty cycle. Second, signal B is a 10% duty cycle. Signal C is a 30% duty cycle. And signal D is a 70% duty cycle. And another important thing while we working on with any rotating structure is, this motors, as I said earlier, it might require a current rating from 25 milliampere to few amperes of current. So if a motor requires some 25 milliampere, then we can directly connect that motor to a microcontroller, because our Atmega 2560 microcontroller will be able to generate 40 milliamperes of current through the GPIO pins. It can source or sink 40 milliamperes of current through the GPIO pins. But if the motor requires more than 40 milliampere, so in that case, our microcontroller will not be able to support it. So in that case, what we have to do? We have to use an external supply, and the external supply should be routed to the motor on the selection from a microcontroller. So the triggering signal will come from a microcontroller. When the triggering signal comes to the this triggering signal will enable the contact between your external power supply to the motor. Thereby the motor will start rotating. So that is one of the reasons we need to use a external motor driver ICs to make a necessary current provision for a particular motor. And the second factor, why do we need to use an external motor driver, is any rotating structure will produce a back EMF. So this back EMF, when it comes to your microcontroller, it might damage your microcontroller. So we should prevent. So we should provide an isolation between our microcontroller and the motor. So in order to do that, we can make use of a motor driver IC. And the third reason for using your motor driver IC is, if I want to change the direction of a motor, so as I show here, if I want to change the direction of a DC motor, I have to take the leads and I have to change the polarity of connection with the battery. So this I need to do it every time whenever I want to change the direction of a motor. So in order to avoid that, we can make use of a motor driver which can do it automatically. By giving some control signals, I can able to change the direction of rotation of a DC motor. So these are the three factors for which we need to have a motor driver IC. So there is a very popular motor driver for DC motor, which is L293 or L293D motor driver. So in this tutorial, I will be discussing about L293D motor driver. So this motor driver is a quadruple high current off H drivers. So which means we can electrically write this motor driver in this format. So which is something like a H. I have 4 switches. So switch 1, switch 2, switch 3, switch 4, and there is a motor in between here. So it looks almost like a H. So that is why it is called as a H drivers. So here by configuring the switches in a proper format, I can able to change the direction of current flow into the motor. When I change the direction of current flow into the motor, what happens? Automatically the direction of rotation is going to change. So for example, here in the first case, I am going to close switch 1 and switch 4, and switch 2 and switch 3 are in open condition. In that case, what happens? The current from the supply, it goes towards switch 1 and it enters into the motor, and it leaves the motor and it passes through switch 4 and it gets grounded here. So here the direction of current flow is in this from left to right direction in the motor. So let us assume the motor rotates in clockwise direction. So if I change the logic of making switch 2 and switch 3 to be in closed condition, switch 1 and switch 4 are in open condition. In that case, what happens? Now the current flows from the battery or a power supply towards switch 2 and it enters into the motor and it leaves the motor and it passes through switch 3 and it goes to ground. So here you can see now the current flows from right to left direction. So the direction of rotation will get altered. So we are not physically removing the motor and changing the polarity. Just by configuring these switches, we can able to change the direction of current into your motor. So thereby there is a change in the rotation direction as well. If I short circuit all the 4 switches, switch 1, switch 2, switch 3, switch 4, then the current from the power supply either will go through 1, 3 and it will go to ground, or it will go through switch 2 and switch 4 and it will go to ground. Now the current is not going to pass through the motor, thereby the motor will be in off state. So here I have shown the same status in terms of a table format. So when all the 4 switches, switch 1, switch 2, switch 3, switch 4 are in open condition, then the motor will be in off state. If switch 1 and switch 3, switch 1 and switch 4 are closed and switch 2 and switch 3 are open, then we are going to get a clockwise rotation. In case of switch 2 and switch 3 being closed, switch 1 and switch 4 being open, we get counterclockwise direction. If all the 4 switches are closed and it is an invalid condition. So such a type of L293D motor driver, it can provide bidirectional drive currents up to 600 milliampere at voltages from 4.5 volt to 36 volt. It can give a current up to 600 milliampere of current. Peak output current of 1.2 ampere is supported. So all inputs are TTL compatible. So we can directly interface this L293D motor driver to your microcontroller. And the applications for this motor driver IC is in stepper motor drivers, DC motor drivers, and also in latching relay drivers. So when we see the pin details of this L293D, so here I have shown the connection diagram of L293D with your microcontroller. So here I can connect 2 motors. Essentially we can connect 2 motors to this L293D. So this pin number 12, pin number 13 comes from your microcontroller GPIO lines. So by providing 0, 1 to this pin number 12 and pin number 13, I will get rotation in one direction. By changing it to 1, 0, I will get the opposite rotation. Same way, second motor can be interfaced with the L293D IC and it can be controlled through the lines from the microcontroller pin number 10 and pin number 11. The same principle applicable here. So 0, 1 will make the motor 2 to rotate in one direction, 1, 0 will make the motor to rotate in opposite direction. And I can enable. So we have an option of enabling the motor 1 alone, and we have option of enabling the motor 2 alone, or I can enable both the motors. So for that I have an enable signal for motor 1 is in pin number 1. So pin number 1 is an enable signal. So if I want to enable motor 1, then I need to give 5 volt to this enable signal. Same way for enabling the motor 2, I have pin number 9. So pin number 9 is an enable signal, and if I want to activate this motor 2, then we need to give a supply voltage of 5 volt to this enable line. And pin number 16 is the supply voltage for the IC. So then we need to connect an external supply voltage. So if the motor requires higher current, then the external supply voltage needs to be used for providing the required current for the motor. So the external supply voltage will be connected to the pin number 8. As I said, this pin number 8 for L293D IC, we can connect from 4.5 volt to 36 volt. We can connect to this pin number 8. So this pin number 8 will act like a external supply voltage. So depending upon the signal from the microcontroller, the external supply voltage will be routed to the motors. So thereby the motors will rotate as per the current rating of its nature. So that is how this L293D motor driver works. So now let us perform a speed control and direction control of a DC motor. So as usual, we are going to use an integrated development environment Arduino for doing our embedded C program, and we are going to build a hardware circuit and try to see whether our program logic is going to work properly or not through Proteus 8 Professional. So this is how we are going to connect our hardware part. So we take an Arduino Mega Board which contains Atmega 2560 microcontroller, and I am going to connect a L293D motor driver to the GPIO pins of your Arduino Mega Board. So I am going to use pin number 4 is connected to in 1 pin of motor driver, and pin number 7 of Atmega 2560 MCU is connected to in 2 of L293D. And in order to enable the first motor, I am going to use the enable signal connected to pin number 3. So here we provide 0, 1 to pin number 4 and pin number 7, which means the motor should rotate in one direction. And how the speed control is achieved? By varying the PWM signal here connected to the pin number 3. By changing the on times, I can change the time of my signal to the motor driver. Thereby we are going to pass it on to the DC motor. So this L293D motor driver is connected to a DC motor through out 1 and out 2 pins, and the supply, external supply voltage which is required by the motor is also connected to your motor driver. Then I am going to connect a potentiometer to one of the ADC channels A1 of your Arduino Mega Board. So depending upon the potentiometer value, my PWM signal will have a different on times of a square wave, and thereby the speed is going to get altered in your DC motor. So by changing the resistance value, I am going to change the duty cycle of a PWM signal. Thereby the speed of the DC motor gets variable. Then we are going to use a switch connected to the interrupt pin of your Arduino Mega Board. So here I am going to use int4 for connecting my switch. So whenever we press a switch, it goes into the corresponding ISR. In ISR, we change the direction of your rotation. So thereby there is a change in the rotation direction whenever the switch is pressed. So whenever an interrupt occurs, it goes into an ISR. In the ISR, we are going to change the direction of rotation of your DC motor. So by activating a switch, we are going to change the direction of the motor. By varying the potentiometer value, we are going to change the speed of a DC motor. So now let us go and first build the hardware circuit using Proteus environment. Then we will move on to the programming part using Arduino IDE environment. Then we will try to simulate it and see. So first let us dive on to Proteus 8 environment for creating our circuit. So on opening the Proteus environment, you will get this window. So first we are going to create a new project. So let me select a new project. So find a location where we are going to save our new project. So I am going to create a folder, DC motor. Select the folder. Give a name for your project with an extension of .pdsprj. So again I will give the same name. It need not be the same name, you can give some other name also. Press next. We need to select a schematic where we are going to build our circuit. So I am going to select a default schematic. Press next. We are not going to do any PCB layout, so I am going to leave it as it is. And I am not going to use any firmware, so I am going to leave it as it is. Next. So now you can see only the schematic is selected. Layout and firmware are not selected. We are not going to use it. Press finish. So you will get a window with this schematic area with the blue box where we are going to build our circuit. So in order to build the circuit, first thing is we need to select the components. So for selecting the components, I go to this pick device on the left side. So I type Arduino in the keyword. Then here you can find Arduino Mega Board. So double click on this, it will get added to your list. Same way I require a DC motor. So I type DC motor. So you can find a simple DC motor. So double click on it, it will get added. Same way we require a potentiometer and a switch. So I try to take potentiometer, add it to our list. Same way I also require a switch. So I take a switch, add it to our project. So these are the things which we require in our program. So after selecting all the items, I press OK to come out. Now we can make use of this selected items to build our circuit. So first let me select the Arduino Mega, place it onto your Proteus 8 environment. I need to connect the potentiometer to pin number A1 of your Arduino Mega Board. So I place it somewhere in the schematic and connect the center lead to your pin number A1. Then one end I need to connect a supply and another end I need to connect a ground. So for selecting power supply and ground, I go to terminals mode, select the power, place it onto your circuit, connect it to your potentiometer one end and select ground, place it onto your schematic and connect it to the other terminal of your potentiometer. So now we have connected our potentiometer value. Then we need to connect the switch. So switch we need to connect it to INT4. So INT4 is here on pin number 2. So here you can see on pin number 2 I have INT4. So we need to connect the switch to this INT4. So here let me show you on how to activate the internal pull-up. So we have internal pull-ups connected to the GPIO pins that we can activate. So by default what will happen if I activated the internal pull-up, this pins will be at logic high. So using a switch, I can make that logic high to go to ground. So I'm going to connect a switch. I go to again components mode, select a switch, place it onto my schematic, connect the pin number 2 to one end of the switch. Other end I am going to connect it to ground because I am going to activate the internal pull-up in the programming part. So when I activate it, this pin number 2 by default it will be at logic high. Whenever I close the switch, it will go to ground. So we will try to use this as a falling edge interrupt. So from high to low, we have a falling edge interrupt. Whenever a falling edge interrupt happens, we go into the ISR for changing the direction of your motor rotation. So I connect a ground to the other end of the switch. So this is for direction control, and potentiometer connection is for your speed control. So now we will connect to a DC motor. Again go to components mode, select the DC motor, place it onto your schematic. So one end of the DC motor, I am going to connect it to pin number 4. Another end, we need to connect a L293D motor driver. So let us select the L293D motor driver. So again go to components mode, pick device, we will select L293D motor driver. So add it to your list. Okay. So now select the motor driver. I'll place it somewhere here. So one pin number 4, I'm going to connect it to in2 of your motor driver, and pin number 7, I'm going to connect it to in1 of your motor driver, and then we are going to use a PWM line. So PWM line needs to be connected to enable 1. So PWM line is your pin number 3. Pin number 3 should be connected to enable 1. So we connect pin number 3 gets connected to enable 1, where we will be generating the pin PWM signal. So here I have connected in1, in2 and enable line. We need to give the supply voltage for your IC to work on. So for that I am going to select again, go to terminals mode, select the power, connect it to your supply voltage pin. Connect it to your supply voltage pin. Then I have pin number 8, where I need to give a voltage for your motor. The power supply required for the motor should be connected to your VS pin. So for that I go to generator mode. You can find on the left side, you can find a generator mode. In that I am going to take a DC source and connect it to your pin number 8. So in order to set the voltage, right click on this, edit properties. So here you have an option of selecting different types of voltages. We are going to select a DC voltage, and I am going to use a 12 volt supply to the motor. So select 12 volt supply, press OK. So that is the supply required for a motor. So now I need to connect the motor to this L293D IC. Again go to your terminals mode, select ground, place it onto your circuit, connect the ground line to your ground terminals of the L293D. Then to connect the motor, I go to components mode, select the motor, place it onto your circuit, connect one end to out 1 and another end to out 2. So this completes our L293D connection. So we have connected the two lines, pin number 4 and 7 to in 1 and in 2, and out 1 and out 2 is connected to your motor, and the PWM signal is going to come from pin number 3 is getting connected to enable 1. We are not going to use second motor, so we have left the remaining part open, and the IC supply voltage is given to your pin number 16, and pin number 8 is connected with the motor supply voltage. So whenever a signal comes from this microcontroller, the external supply voltage will be routed to your motor for its operation. And we have a switch for changing the direction of a motor, and we have connected a potentiometer for varying the speed of a motor. So now let us save the circuit. We are ready with our circuit. Now we have to go and build our embedded C program. So in order to do that, we open the Arduino. So here you can find, first thing is I am going to use pot variable for initializing it to A1. So this A1 is required because we have connected a potentiometer to A1 terminal of your Arduino Mega Board, and we define a Boolean logic M1 and M2 initialized with high and low. So the motor will rotate in certain direction, 1, 0. So then in the void setup function, we need to set the configuration for our system. So pin number 4, where we have connected to our L293D, is configured as an output pin. Same way pin number 7 is also used as an output pin, and pin number 3, which we use it for PWM signal generation, also configured as an output pin. Then we have connected a switch for direction control to pin number 2. So this pin number 2, we are setting it as input and also activating the pull-up. So thereby the pin number 2 by default will have a 5 volt. Whenever I press the switch, what will happen? It will get grounded. This pin will go to ground. So this is the pin configuration. Next, we are using this pin number 2 as an interrupt pin. So for enabling the interrupt, I use this function attach interrupt digital pin to interrupt pin of pin number 2. So we are converting this digital pin into an interrupt pin. And when the interrupt occurs, I am going to execute an ISR named motor. Okay, this is the name of the ISR, interrupt service routine. And when the interrupt should happen, it should happen on falling edge. So whenever there is a transition from high to low, then the interrupt will occur. So that is why we have enabled the internal pull-up. Whenever I press the switch, it will go from high to low condition, thereby interrupt will be generated. So this completes the configuration part in your setup program, which runs for only one time. Next thing is we are going to do it in loop. So in loop, where the program runs continuously infinite number of times. So here I have initialized a variable called as PWM ADC. And we are going to read the potentiometer value using analog read function. So analog read function will read the potentiometer value. Potentiometer is nothing but A1, which we have already declared. So we are going to read the analog value in pin number A1. So that goes to your PWM ADC. So since we have a 10-bit ADC, so my value in PWM underscore ADC will be any value between 0 to 1023, because 2 power 10 is 1024. Since the value starts with 0, it ends at 1023. So our PWM signal variable will have a value between 0 to 1023. So in order for PWM to get activated, we need to convert this PWM from 0 to 1023 to 0 to 255. It's a 8-bit scale. It's a 8-bit PWM we are going to convert. So 8-bit PWM in the sense, my duty cycle can be any of the 256 variations of my duty cycle. So 2 power 8 is nothing but 256. I can have 256 different on times are possible. So our scale from 0 to 1023 should be converted to 0 to 255. So for that we make use of this function pwm underscore adc by 4. We are dividing the value, whatever value we are getting through the pwm adc, we are dividing it by 4. So it comes within the range of 0 to 255. And this value is sent as an enabled signal to your L293D. And the logic for your motor 1, M1 and M2, M1 is high and M2 is low, and it goes to the pins 4 and 7, which means the motor will rotate in certain direction, which is dependent on this PWM line. Then we have, whenever we press a switch, it goes into an interrupt generation. So whenever interrupt is generated, what we do? We need to change the direction of a motor. So how to change the direction of the motor? Whenever interrupt is happened, it goes into an ISR. So ISR is written here. So ISR, here you see not of M1 and not of M2, which means initially M1 is high, now it will change to low. So initially M2 is low, now it will change to high. So thereby the values to your pin number 4 and 7 will get changed. Thereby the direction change will happen in the motor. So by pressing a switch, an interrupt is generated. In the ISR, we change the direction of motor, and in the main loop, we read the potentiometer value, convert this potentiometer value to a value between 0 and 255 and send that value to your enable line. So depending upon the enable line, the speed of the DC motor will get altered. So now let us save this program. Let me save this program as DC motor with an extension .c. Save this. Then we have to compile this program and convert this embedded C program into a hexadecimal file. So for that, we go to Sketch, Export Compiled Library, which means it will do both the compilation and also convert this high-level language program to a hexadecimal file. So convert this program. So once you go to that folder, so no errors. So once you go to that folder, you can find a hexadecimal file. So this is the file which we are going to dump it in your hardware program memory of your Atmega 2560 microcontroller. This is the hexadecimal file which we are going to dump. So now let us go to Proteus. So here right click on this Arduino Mega Board, go to Edit Properties. Here you select the program file. So program file, I am going to select the DC motor, the hexadecimal file. We are trying to import this hexadecimal file into the program memory of your Arduino Mega Board. Then press OK. So now we have imported it. Now let us check whether our program works properly or not. So for checking, here I have a play button on the left side bottom. Press this play button. Now you see the motor is rotating in anti-clockwise direction. Now let me change the speed of rotation by pressing this potentiometer value. So when I increase the potentiometer value, you can see the speed increases. Right? So the motor rotates at a faster rate. So when I reduce the potentiometer value, you can see the speed will reduce. You can see now the motor rotates slowly. So if I want to change the direction, then I can press this switch. by creating an interrupt, you can see when I see, now it starts rotating in clockwise direction. Again, if I want to change the direction of the motor rotation, again I press a switch, you can see now the change in direction of the motor rotation takes place. So this is how we can do the variation of speed of a DC motor, and also the changing the direction of a DC motor can be accomplished. So in this tutorial, I have discussed about on how to use a L293D motor driver for interfacing your DC motor with Arduino Mega Board, and on how to do your speed control of a DC motor and how to change the direction of a DC motor using Arduino Mega Board. Thanks for watching. Please subscribe for more technical learning. Thank you.